Bismillahirrahmanirrahim. Assalamu alaikum. Let's start chapter 7 of D2, and this chapter is about relations and functions. Okay, and it's a very basic chapter to learn something about relations and function. So let's start with a relation, and when we talk about relation, we have done something already which relates to relation. Like we've been dealing with equations, and when we have equation, we have equality sign, and we have a left hand side and we have a right hand side. So what is happening? Left hand side is equal to right hand side. In a way, you are saying left hand side is related to right hand side. Whatever change is happening on the left hand side is also going to affect the right hand side. Okay, so it's a relation. So let's start with that. So when we talk about relation, we have already dealt with the equality sign, and so let's take an example. Y is equal to 3x plus 2. Okay, so it's an equation. So left hand side is equal to right hand side. This left hand side is related to this. So whatever is happening on the right hand side is going to affect the left hand side as well. Okay, and when we were making graph for these linear equations, we used to make the table, and that table was also was a way to show the relation between the x values and the y values. So let's make that table. Okay, x, y. I take x as minus 2, and what do I get here? Minus 4. I take x as minus 1, y is minus 1. If I take x0, y is 2. Take x1, y is 5. Okay. So it's a tabular form, and it's a relation of x values with the y values. Okay. This x values are actually domain, and these y values are actually codomain or range. So whatever the values are in the domain, which are the x values, are related to the values in the codomain, which is the y values or the range of the x values. So we can see here in the tabular form that the x values are related to y values. If we input minus 2, we get minus 4. If we input 0, we get 2, right? So tabular form. So we can also use the same values, and we can go for a mapping of x values with the y values. So let's do that. These are the x values, these are the y values. So minus 2, minus 1, 0, and 1. Okay, so if I'm going to have here minus 4, minus 1, 5, and 2. Okay, so minus 2 is related with minus 4, minus 1 is related with minus 1, 0 is related with 2, and 1 is. So it's a mapping of x values with the y values. Here, of course, it is domain, and this is codomain or range. Okay, so relation. We started from an equation, so it's a tabular form. It's a relation to mapping. It's a relation to. So now we see that how the x values are related to y values. Okay, the left hand side is related to right hand side. Now, if we have this idea of relation, now let's come to function. So what is a function? So function is also a relation, but when do we call that this relation is a function? So what is that? So let's come to that. So function. For a function, we define it as it's a rule which relates x values with the y values. Okay. How? Let's say we have x values, which is input.
Allahu Akbar, Allahu Akbar, Allahu Akbar, Allah.
And then we are going to have a rule here. And after passing it through the rule, we are going to get y values, which is output. Okay, so we're going to have an input. It will pass through a rule, and then we will have an output. So it will be a function. But for a function, there is something very important. Okay, as I said that there is something important for a relation to be a function. For every input value of x, there has to be only one value of y output. So one input, there has to be one output only. This is important for a function. What I mean, like if I have here 2, 4, 6, 8, 1, 2 and 3. And if I say that okay, this is my x values, this is my y, this is input, this is output. So after passing through a rule, what I am getting is 2 is related to 1, 4 is related to 3, 6 is related to 2 and 8 is related to 3. So it's a function, right? For every input there is one output, every input there is one output, every input there is one output. That is fine, it's a function. So it is a function. Now if I take the same example, 2, 4, 6 and 8, 1, 2 and 3. Okay. Now in this example, if I say 2 is related to 2 and 2 is related to 2 also, 4 is related to 2, 6 is related to 2, 8 is related to 3. Now this is not a function. Why? Because if I input 2, what am I going to get? 1 and 2. So there are two values of y, not a function. Okay. So let's take an example here also. So we have an equation y is equal to 2x. So if I input for x, I input 1, what do I get? 2. Values are doubled. If I input 2, what do I get? 4. If I input 3, what do I get? It is 6. So values are doubled. For every input, I am getting 6. For every input, I am getting one output, right? So this is the case of a function. Now let's take another example. Y square is equal to x. Okay. For this, if I input 9 here, this is y square, right? I am going to input, so y square is equal to 9. So what will be y? Y is going to be, so actually it is like y square is equal to 9. So y is equal to plus minus 3. So it is plus 3. It is also minus 3. So for one value of x, I am getting two values of y, not a function. You see, like this, 9, 3, minus 3. So two values of y, not a function. Okay. So for a function, one input, one output. It's a rule. Okay. Now let's talk about a notation of a function. Okay, the functions are usually written as f colon x y, and what actually it meant is, so it's a function from x to y, function from x to y. It's a function from x to y. Okay, so it's a way of mathematical way of writing a function. So function from x to y. Now suppose now we have two functions f and g, and let's do some examples with those two functions f and g. So I have f So it is a function from x to 10x plus 4, and is a function g from x to 4x minus 6. Okay, so here x is we are going to have x values, we are going to have y values, but we can write it in a more simpler way, so we can understand it in a better way. What we can do is, for this part, what we are going to do is fx. Now fx means that it's going to be our range equals, like y is equal to something, y is equal to 2x. So this is sort of y, 10x plus 4, and gx is equal to 4x minus 6. We can write this in a equation form also. And when these functions are written in this equation form, you can deal with these functions more easily. So if I say here, I have to find the value of f minus 7. Now it is pretty easy now. It is clearly understood that what is here? This is replacing actually x. So f minus 7 equals, replacing x with minus 7. 10 into minus 7 plus 4. So basically it is minus 66. Okay? And if I say here I have to find g2, I'm going to replace x with 2. So g2 is equal to 4 into 2 minus 6, which is 2 again. So pretty easy, right? Okay. Now let's do a couple of more examples. So if we have to do like this, f2 plus g1. Okay. Now what do we have to do? 10 into 2 plus 4 plus 4 into 1 minus 6. So it is basically 20 plus 4, 24 plus 4 minus 6. So 24 minus 2 is equal to 22, and it is negative. Okay? And find x for f x equals gx. If these both functions are equal, then what's the value of x? For this, what do we have to do? 10x plus 4 equals 4x minus 6. So 10x minus 4x is equal to minus 4 minus 6. So 6x is equal to minus 10. So x is equal to minus 10 over 6, which is minus 5 over 3, or you can in a mixed form you can. So this was a basic about the functions and the relations. We'll do more about functions in the some chapter in the D3. We'll do more about that. But right now, for the time being, it is the basics about the functions, just to understand the notation and to know when we call a relation a function and when it is not a function. Okay? Thank you very much.